Welcome to Unit 3. We are going to be doing some exponent rules. So, exponent rules, there's 4 of them. But, take a look at number 31. What I want you guys to do is work on these exponent rules. But number 31 is kind of a sneaky question. We will talk about it later on in the chapter, but I don't want to include it here because all of the problems you're looking at in this section are monomials. Monomials are not separated by plus or minus signs. Like this guy here, 31, these are binomials here. That guy's a binomial. That guy's a binomial. Same thing goes with 32 over here, but that's not even assigned. I just want you to do the odd ones. If you ever feel like you need extra practice, you may do the even ones too, but I'm going to just collect the odd ones. So 23 to 49, odd is what I'm looking for. So you can take a picture of it. You can scroll down, take a picture of it, or fast forward, you can't scroll. Take a picture, and then here's the last one. Stop here at 49. Now here's the thing. I am using a different book. The reason I'm using this different book isn't because I hate our book. It's because this book that I chose has a very detailed answer key. They show every single step. So for number 23, they show all their steps. There's the final answer, whoops, is right there. Same thing with this guy, number 24. Now here's the thing though I want you to understand. They wrote the answer as 9/2 x to the 7th. That's the same thing as 9x to the 7th over 2. They are identical answers. Sometimes it's just easier to typewrite the book a certain way, and that's why they do it. But it doesn't happen for all the answers. Here I could write this as x to the 14th over 5. That's the same as 1/5 x 14th. That guy, though, that's all you could do for that one. But look at what I'm saying. They show every step until they get to the final result. So I like to give these practice problems because if you get stuck and you're like, I don't even know if what I'm doing is the next move, you could do it. Remember, 31's off the book, so we don't care. Don't care about 32. And then once again, any of the evens you could do if you'd like to check your work. But I'm just looking ahead here. I don't see anything else that's peculiar except for this guy right here, 8/9 v7. Could be 8v to the 7th over 9. And then here's the other part of the answer key. So stop here at 49. And you'll see they have all their answers written out for those. So let's talk about exponent rules, because there are some rules that confuse people because they just never bothered to practice it enough to get it right. So the power rule. See, here's the thing with the power rule. If I gave you something like 2x to the 3rd, y to the 5th, and then I told you square that thing, you would then distribute this power in. Remember, every number has an exponent of 1. We don't write it in, it looks weird. But what's really happening is, and this is what the book shows in every step, they're showing it's 2 to the 1 times 2, so 2 squared. In the book, they're going to write x to the 3 times 2, y to the 5 times 2. They're going to write out their intermediate step. However, if you know that it's going to be 2 squared and 2 squared is 4, and you don't write that step in for me, that's fine. I don't write that step in. I don't. But the thing is, this is called the power rule. When you have anything, whoops, come on, and they give you an exponent on the outside, you should always do this rule first. The power rule should always be the first thing you look at, because this guy is the only rule like it. That's not x to the 7th. That's x to the 12th. That's not y to the 7th, or sorry, y to the 10th. That's y to the 21st. When the power comes from the outside, when it's distributed on the parentheses, it multiplies. That is the power rule. Now, some people say, well, how come we can't do that like this then? How come this isn't true? Well, this means x plus y times x plus y times x plus y. That's what that means. So if you were going to multiply that thing out, you are going to get a whole bunch of junk. You're not going to just get this. That is not the answer. It's not. I'm trying to do this in my head while I'm thinking about it, but I think if you really are bored and you want to check me, I think this is what that answer turns out to be, which is definitely not this. You're missing all kinds of information in the middle. So people say, well, then how come I can do it here? How come I get to do the trick right there? Well, let's examine that. If I had x4, y7 times x4, y7 times x4, y7, that would be the same thing as this. But see, these are not binomials. I don't have to FOIL any of this junk. I can just say, hey, x to the 4th times another x to the 4th times another x to the 4th is x to the 12th. Y to the 7th times y to the 7th times another y to the 7th is y to the 21st. See, I'm not foiling here. Here I would have to do a big old FOIL party. Here I don't. So where this right here is a total no-no, we never do that. Look, this is the shortcut to get the same answer. Well, wait a minute. So if you write it out like this, and then you add their powers, you get the same answer. That is true. This is just shortcut. This is a shortcut. And this shortcut only works when it's a monomial. There's no plus or minus sign between that stuff. You don't have to do the shortcut. You could write it out the long way every time and then just do this where you add their exponents. Add their exponents. That's called the product rule. The product rule is when you add exponents. So anyway, let's take a look. Like x to the 3rd, y to the 6th, times x squared y to the 1st. I didn't write it in, so it must be a 1. And then this is just the product rule, so I would just add their powers, x to the 5th, y to the 7th. There's nothing outside here. There's no power getting distributed. So what would it be? It'd be like if they wrote a 1 here. But 1 doesn't change anything when you multiply it, so we don't have to write it in. What I'm trying to get at is this. There are 4 rules. The first of them is called the power rule. You should always do the power rule first. The power rule is the only time you will multiply powers, ever. Then there's the thing called the product rule. So the product rule could come second. Here's the thing. It could come second if you wanted it to. It totally could. This could also come second. What about this one? What about this one? If I did the quotient rule. The quotient rule is when I have stuff like this. Let's say x4, y2 over x3, y6. The quotient rule is when we subtract exponents. This is when we subtract exponents. See, I could just say, I am more powerful than you. How much more powerful is the numerator? It is 1 more powerful. What about these guys? What about the y's? Who's more powerful, top or bottom? The bottom is more powerful. By how much? By 4. How did you find that answer? 6 take away 2 is 4. Now, here's the deal with this. I said this could be second, or you could do this second. Guess what? There's one more rule we have, but I don't want to get there yet. I want to just kind of play with these two for one more example before I go into the second thing. But let's suppose I gave you something like this, and I said, let's throw a number in this one this time. 2x times 3xy4 over 6xy5. See, if I wanted to, I could use the quotient rule first. I could say 2 goes into 6 3 times. 3 goes into 3 once. I have reduced my numbers. That's a quotient rule thing. Well, you're not subtracting. I'm not. They're not exponents. Those are numbers. Numbers do what numbers have always done. If you have numbers in the top and numbers in the bottom, you can reduce them. They are numbers. But if I did this now, I said, hey, x to the first knocks out x to the first. Hey, there's a y to the fifth and the y to the fourth. I'm going to just collect what's left over. This guy is the only thing left in the top. And then 5 take away 4, that's the only thing left in the bottom. That was me doing the quotient rule before I did the product rule. Well, what if you do it the other way? Let's take a look. What I'm trying to say is, it won't matter. Let's start with the original question, 2x, and then there was 3xy4. And then on the bottom there was 6xy5. So if I do the product first, that would mean I'm going to do the top part. So I'm going to do 2 times 3, 6, because they're numbers. Numbers do what numbers always do. They're not exponents. But here I have an x first times an x first. I call that x second, because I'd add their powers. There's a y fourth with nobody else to hang out with. Let's copy down the bottom, because I haven't even done anything with it yet. Well, let's now do the quotient rule. 6 is a number, 6 is a number. 6 sixths is 1. I reduced it, it's done. I am more powerful than you are. How much more powerful? 1 more powerful. I am more powerful than you are. How much more powerful? 1 more powerful. Do I have to write the 2 exponent 1s in there? No, but you'll see, look, same answer. So the confusing thing about exponent rules are, a lot of people go, well, you're doing it wrong because you did this before that, or I did this better than you. You know, here's the supreme rule you should always think of. Always do this one first. If you see an exponent on the outside, do it. Then, it doesn't matter which order you do the next guys in, as long as you don't make a mistake, you'll get the same result. So, I always say there are 4 exponent rules. The first rule is called the power rule. That's the only time you will multiply powers. The only time we multiply powers. I did not say multiply numbers because the second thing we could do could be any of these 3. It could be the product rule. That's when we add. It could be the quotient. And that's when we would subtract. And then the last one is negative exponents. That's when we change locations. That's when we change locations. Well, let's talk about the negative rule since we haven't done that one yet. Well, it's pretty simple. Let's do something like this. I'm going to do x to the third, y to the negative 2, z to the negative 1 over x to the second, y to the negative 4, and z to the fifth. Well, this guy has negative exponents in it. So here's the thing with that. Negative exponents are location changers. Think of any fraction. It's either in a numerator or it's in a denominator. So when the exponents are positive, like here, x third, x squared, they are not going to change their position. One of them is more powerful than the other, so you can reduce it. You could say, I am more powerful than you are by 1. So the top part would remain with the exponent. But when you have a negative power, the job of a negative exponent is to relocate you. I'm going to use a different color here. And I'm going to say, if I let this negative do its job, what it's going to do is it's going to send this guy to the bottom, and down over here, it's going to send this guy to the top. That would mean y to the fourth is now in the numerator, y to the second is now in the denominator, and once you relocate, this is the part you got to pay attention to. Once you relocate, the negative has done its job, and there is no more negative there. So let's look at this one. Do you see that this guy has no negative on him? Z to the fifth. That means he's going to stay put. He is not going to travel. But this guy has a negative exponent, so it's going to move. When that guy comes downstairs, z to the fifth is sitting here all by himself. Here comes this guy, z to the first, because once it relocates, its negative has done its job. So now it's on the bottom. Now it's a product. So it's going to be z to the fifth times z to the first. Heck, we'll call that thing z to the sixth, because 5 plus 1. Now, when you say 5 plus 1 gives you z to the sixth, you'll notice when you look at the answer key, they'll show that little plus sign. They'll go like this, because they show every single step in the answer key. So if you get stuck and you're like, what did they do next? Look at the answer key. That's why I picked out these problems. But you don't have to write out that step. You don't have to be that detailed. Now, take a look at this. Remember, that stemmed from this right here. Right here. When this guy relocated and this guy relocated, this is what I ended up with. So now you ask yourself, who's more powerful, y to the fourth or y to the second? Well, y to the fourth is more powerful. How much more powerful? By 2. That's my final answer. Negative exponents have one purpose, and that is to relocate you. If the information is in the denominator and it's negative, it will become positive in the numerator. If it's a negative exponent in the numerator, it will be rewritten as a positive exponent in the denominator. So the negative exponent rule makes up the fourth thing we do with exponents. Just remember, as long as you do this one first, any of these three could be done second. The order does not matter. Sometimes it's easier to do this one before that one, or vice versa. You will get the same answer as long as you don't make a mistake. So let's take a look here. I'm going to scroll back up to the top and say, like this problem here, number 23. Well, it says 2x, the whole thing to the fourth, then times x third. So what did they do? They distributed that power, and then they wrote it out as every step there. Then they showed their next move, and I told you they would do this thing, so you could get to the final result. Now, let me take a look at something a little bit more complicated, like number 27. I'm not going to do your homework for you, but I don't have to. There is a perfectly good looking problem right next to it that's number 28. So something very similar to that. I'm going to just tweak it a little bit in case you want to try number 28 on your own. So how about I do this? I'm going to go parentheses, 3x to the third to the negative 4. And then they had something else over here. They had something like 4x negative 2. All right, the supreme rule is this. This guy has got to go first. Once I do this, then I don't have to, but remember, this is 3 to the first power. So in the book, they're going to write this out. 3 to the negative 4. This is the only time I multiply, so that's x to the negative 12. Then I'm going to have this times 4x to the negative 2. Now be careful. Look at the subtle difference here. This negative 4 is on the outside of parentheses, so it gets distributed. This negative 2 is not on the outside of the parentheses, so it does not affect the 4. It only affects the x. So here we go. I am choosing in my reality to make this look like a fraction now because I don't want to confuse myself. I am going to choose to make this look like a fraction now if I want to. Negative exponent. This is going to make this part of the problem go downstairs. Negative exponent. That's going to make this part of the problem go downstairs. Once it travels, what's going to hold the place in the top? 1. Once it travels, it's downstairs. I am now 3 to the 4th downstairs. I am now x to the 12th downstairs. 3 to the 4th is just a number. I can punch it in on my calculator. 3 to the 4th is 81. So I now have 1 over 81 x to the 12th. But I haven't done anything else yet with the other part. So once again, let's examine this. This negative 2 is not on the 4, it's only on the x. So what's going to happen is the 4 is going to stay put. This guy is going to travel down. I already cleaned up part of the problem, so let's bring it down now and complete this. On the top, I just have 1 times 4. 1 times 4 is 4. 81 has no one to play with. 81 times, well, this is when I would be using the product rule. Am I going to call this answer x to the 24th, or am I going to call this x to the 14th? 14th. Because the only time I will ever multiply exponents is in the beginning when it's the first thing I do. So that's an example of how we use all these rules. Now, I know you go through these rules in Algebra 1. I understand that, but what they do in Algebra 1 is they do them each separately. One day they show you this trick, and then they show you the other trick, and then you come into Algebra 2, and what do I do to you? I go, hey, see this problem here? It could happen. You can do all this stuff at the same time if you want. So let's see, how did they get this answer? So 42, let's do something like 42. So I'm just going to play with this. I'm just dinking around. So 2x 2 y negative 3, let's cube it. And then we'll do something like this because this is what they had in the book. 3 x negative 1 y to the negative 2, something like that. What is the grand supreme rule of all time? This guy comes in. None of this stuff is binomial. This is a monomial. This over here, monomial. There's no plus or minus signs between the terms. Monomials. And let's start with the first one. I will get 2 to the third. Now 2 to the third means 2 times 2 times 2. I get 8. If you want to write out that middle step, if it helps your brain, do it. But me, I just like to take care of numbers and get them done. So it's 2 to the third, that's 8. X to the sixth, because 3 times 2 is 6. And then y to the negative 9. I am done multiplying. But you know what? I'm going to make it look like a fraction because I see that there's one piece of the puzzle that's going to travel. It's not the 8. It's not the x to the 6th. The y to the negative 9 is a traveler. Now, I'm going to see what happens over here. I'm going to get, now this one I'm probably going to write a middle step in because I see I'm going to get 3 to the negative 2. I'm going to get x to the regular 2 and y to the negative 2. The reason I wanted to kind of separate this is say, what's going to happen to that? If it travels downstairs, I'm going to get a 9. See, I like to take care of numerical stuff separate than letter stuff. And then I'm just going to fill in the blanks here. Now, if I wanted to, I could start tossing things up and down and whatever, but I want to show you. I can do product rule next if I want. I don't have to do it in any certain order as long as I've done the distribution of the power first. Everything else can be second. So I'm going to multiply straight across. 8 times 1 is 8. On the top, x6 times x second is x to the 8th. Y to the negative 9 times y to the negative 2, I would add their powers because I didn't change their location yet. And then 1 times 9 is just 9. This answer is not considered correct yet because they want no negative exponents in their final answer. So, if I wanted to, I could say 8, you're staying up top. X to the 8th, you're staying up top. 9, you are staying in the bottom, but y to the 11th, you are going to travel. And I am going to call you the answer now. So please understand that as long as you distribute the power, you can do any of the other ones next. You just got to make sure you don't break the rules. And when I say break the rules, don't accidentally multiply powers instead of add them. Don't accidentally, add them instead of subtract them. Know what it means to relocate something to have only positive exponents. That's the object of the game here. Now, there's this guy right here. I gotta show you. Oop, that's the answer key. So, answer key. So look, we're stopping at problem number 49. So I want to make sure that you understand this with 49. They have a big old parenthesis on the outside. So they had this. They had something like this. 4x 2 y negative 1 z negative 3 over, and then they had something like 2 x to the negative 1 y to the third z to the fifth, and then they stuck a exponent out here. That means everybody's getting hit by that thing. I am going to drop it like it's hot on all this stuff, and it's going to go all the way to the bottom too. Bam, boom, and hits everybody. Everybody gets hit with this. So let's say 4 to the negative 2. That's what that's something I'm going to have. 4 to the negative 2. Then I'd have x to the negative 4, because I multiply powers when they're coming from the outside. Y to the second, because negative 2 times negative 1 is positive 2. And then here I would get z to the sixth. But I am not done. I'm going to drop it like it's hot down below. 2 to the negative 2. I will then get x to the second. Second. I will get y to the negative 6. I will get z to the negative 10th. Now, personal preference. If I see numerical stuff, I take care of it. So what does it mean? It means 4 squared goes downstairs. This is going to change location. 4 squared would make 16. This is going to change location. 2 to the negative 2 means change my location. Put the 2 squared up above. That's what's going to happen there. Now, I'm going to use a different color because I think it'll be helpful to follow along. And I always work alphabetically. So I'm going to go with the X's. Who is staying put, top or bottom? Bottom staying put. This guy's going to come down. That means when he comes down, there's going to be x to the second times x to the fourth. That's going to give me an x6 down in the bottom. Let's mess with the y's now. I'm going to go to the y's. This guy is positive. He's staying put. This guy is negative exponent. He's going to travel. So what's going to happen is y to the second is just sitting there minding its own business, and y to the sixth comes up, and I add their powers. And I'd say y to the eighth. Last but not least, who's traveling, top or bottom? The bottom z is going to travel. He's going to come up. This guy's going nowhere. So I have a z6, and then z10 comes to visit, and we call it z16. And you don't get this answer in the back of the book because they would reduce the two numerical values. You would say, hey, 4/16, those aren't exponents, those are numbers, and numbers still reduce each other. Biggest mistake people make is they panic and they go, well, those numbers have to stay exactly how they are. No, you can reduce numerical values. Remember, numerical is not exponent. 4 goes into it once. 4 goes into that 4 times. Now I've got a final answer, and it's beautiful. This is a beautiful final answer. I have y to the 8th, z to the 16th, the whole thing over 4x6, and that's a great answer. Me gusta mucho. All right, guys. So here's what I want you to do. I want you to try these problems. You're going to find maybe a couple of them are a little tricky, but I want to see what you guys come up with. Once again, this is the answer key. Look, these are the answers. Answer key. All right, etc. Here's the questions. Now it says, simplify the expressions and eliminate any negative exponents. That means if there's a negative exponent, you blew it in the answer because none of your answers should have a negative exponent in them. But word to the wise, the ones that I think might trip you up a little bit are 39 and 41. Let me explain. In 39, they have this sneaky thing here. Well, remember, if they don't put that b to the second on the bottom, you could rewrite that like this. Okay? Also, where it says 12b to the negative 8, you can put a 1 there. And then you could ask yourself, is the negative 8 on the b? Is it on the 12? Or is it on both? And act accordingly. And problem number 41, hey, put 1s here and make it look like a fraction. It might help your brain out. Sometimes it's just in the way you perceive the problem that makes it doable. So once again, what do I want you to do? 23 to 49 odd, skip number 31 because 31 has binomials. We'll talk about that later. And check your answers as you go. And always remember, if you get stuck, ask. I will help you out. And then answer key, you can pause it, take a picture of it, etc., etc. Okay. All right, guys. The next lesson is like super short video because you already know how to do everything if you know these rules. So here's the work. Sorry, I'm moving it all over the place. Pause it, take a picture of it, and good luck.